go through all uncertainties in 5 minutes, so pay very close attention. Okay, suppose u is equal to x times y times z, right? What is the maximum fraction error in u? So this formula is usable when you're multiplying or you're dividing in uncertainties. For instance, in this case we are multiplying. U is equal to x times y times z. So the maximum fractional error in u will be equal to plus or minus fractional error will be equal to plus or minus the absolute error in x over x plus the absolute error in y over y plus the absolute error in z over z. Since u is equal to x times y times z, let's go through some worked out examples. Pay very close attention. So question 1 saying that the mass of a block of metal is 11.5 plus or minus 0.5 kilograms and its volume is 1000 plus or minus 20 cubic centimeters. Right? So the first question now is saying that how would you express the density rho of the metal, right? So let me just take a blank paper and work this through. Firstly, let's take note of the question. The question is saying that how would you express the density rho of the metal, right? So what is the formula for density? So the density rho is equal to mass times volume. That's the formula for density, right? So what is our mass? The mass is equal to 11.5 plus or minus 0.5 kilograms, right? That's the mass. Then the volume now, the volume is equal to 1000 plus or minus 20 cubic centimeters. That's the volume, right? So we want to calculate the density now. Okay, we want to calculate the density of the block of metal. Okay, so firstly we'll start by calculating the density only. For the moment, let's leave out the uncertainty part. Okay, so therefore the density will be equal to the mass, which is 11.5, divided by the volume, which is 1000 cubic centimeters. So for the moment, the volume will be equal to 0.0115 kgs per cubic centimeter, but we have not factored in the uncertainty now. Okay, so it's now time to calculate the uncertainty. Okay, so according to the formula, the uncertainty in rho, which is the density over rho, will be equal to the uncertainty in m over m. So the uncertainty in m, uncertainty in mass over mass, plus the uncertainty in the volume over the volume, right? So that will be the uncertainty in rho, the density, right? So let's move on. Okay, let's come down here. So the uncertainty in rho over rho will be equal to, what is the uncertainty in the mass? The uncertainty in the mass is 0.5. This is the uncertainty with the absolute error. The absolute error in the mass will be 0.5 over the mass. The mass is 11.5 plus the absolute error. Absolute error or the uncertainty is just the same thing. Saying uncertainty or the absolute error is just one and the same thing. So absolute error in V, which is 20, over V, the volume, which is 1000. Right? So this is the absolute error in rho. Right? This is the absolute error in rho. So therefore, you take your calculator, you punch in 0.5 divided by 11.5 plus 20 over 1000 is equal to, if you punch this into your calculator, the absolute error in rho over rho will be equal to 0.0663 corrected to 3 decimal places, right? So now we need to calculate the absolute error in rho, right? So therefore, to calculate the absolute error in rho, the formula will be like this. The absolute error in rho will be equal to 0.063 times rho. Rho will just multiply this. Okay, we've just made absolute error in rho the subject of the formula. Okay, so therefore the absolute error in rho is equal to 0.063. Okay, so what is rho now? We've calculated rho, which is the density, which is 0.0115. That is rho. Okay, of bracket multiplied by 0.0115. This is the absolute error in row. You can just punch that into your calculator. So if you punch this into your calculator, 0.063 times 0.0115, the solution will be the absolute error in row will be equal to 0.0007, corrected to the nearest 4 decimal places. So therefore the absolute error in row is equal to 0.007. Okay, so therefore the final solution to the question, keep in mind we've calculated row from the very beginning. Row is 0.0115. Okay, but the uncertainty in row is 0.007. So therefore the final solution to this question would be row, which is the density of the block of metal, is equal to 0.0115, right, plus or minus 0.0007 kgs per cubic centimeter. Kgs per cubic centimeter. Okay, I had run out of space here. Basically it's cubic, kgs per cubic centimeter. This is the unit, right? So therefore I hope you were not lost in the process. So we've calculated the uncertainty in the density, and first we had calculated the density, right? So therefore final solution to the first question is rho is equal to 0.0115 plus or minus 0.007 kgs per cubic centimeter. Okay, so let's proceed to the next question. So if you're lost in this first question, don't worry. We're going to calculate the second question. It's just based on the same principle. Okay, so we're moving on to item 2 of question 1. So the first question was telling us to calculate the density of the metal, right? So we calculated the density and we found that the density was equal to 0.0015 plus or minus 0.007 kgs per cubic centimeter, right? So the second question now is now telling us to calculate the percentage error in rho, percentage error in the density. So this is a very simple question. In calculating the percentage error, you use this formula. So therefore, the absolute error in rho over rho times 100 is equal to the percentage error. Is equal to the percentage error. So that's the formula, right? So what is the absolute error in rho? The absolute error in rho is 0.007, right? So 0.0007 over rho. What is rho? Rho means the density. What is rho? So rho is 0.0115. 0.0115 times 100 is the percentage error. Okay, so let's punch that into the calculator and see what we get. Okay, so if you punch this quantity into the calculator, you get that the percentage error will be equal to 6.009 corrected to 2 decimal places percent. So the percentage error is 6.09%. Then you're done. So let's move on to the second question now. Question 2 reads, the diameter of a wire is 0.056 plus or minus 0.1 millimeters. So item 1 of the question is saying that what is the cross-sectional area of the wire? And item 2 of the question is saying that calculate the percentage error in the cross-sectional area of the wire. Okay, so before we attempt question 2, before we attempt to solve question 2, I want you to take note of something here. Okay, so these are the last concept we're going to go through in this question. Okay, these are the last concept in uncertainties. Okay, so the first concept I want you to take note of is that if you are multiplying with a constant, right? For instance, u is equal to cx, where c is a constant, right? So the absolute error in u will be multiplied with that constant. So therefore, the absolute error in u is equal to plus or minus c times the absolute error in x. You get it? So the absolute error in u, since u is equal to cx, where c is a constant, so the absolute error in x will be multiplied with c. Okay, so that will lead us to the absolute error in u, right? So therefore, the absolute error in u is equal to plus or minus the absolute error in x times c, which is the constant. Then the last concept I want you to keep in mind also before we solve question 2 is that when you have a constant power, for instance, u is equal to c u is equal to x to the power p, I mean. For instance, u is equal to x to the power p, where p is a constant power and a non-changing power. So therefore, the absolute error in u over u will be equal to plus or minus the constant power times the absolute error in x over x. Or in simpler terms, this is just the fractional error in x. Okay, so take note of this concept. Okay, so these are the concepts that are going to be used to solve question 2. So let's go back to question 2. Question 2 is given us the diameter of a wire, which is 0.56 plus or minus 0.01 millimeters. This is the absolute error in the diameter, right? So item 1 of the question is saying that we should find the cross-sectional area of the wire. Okay, so what is the cross-sectional area of the wire? So the cross-sectional area of a wire is equal, cross-sectional A of a wire is equal to pi r squared. This is the formula for cross-sectional area of a wire. But take note, the question didn't give us r, which is the radius. The question is giving us d, which is the diameter, where d is equal to 0.056. Apologies, my error. D is equal to 0.56 plus or minus 0.01 millimeters. Okay, so this is D. Okay, so the question is giving us D, which is 0.056 plus or minus 0.01 millimeters, right? And the question is demanding that we calculate the cross-sectional area of a wire. So we want to first narrate the relationship between R and D. D being the diameter of a wire, then R being the radius of the wire. So we know that D is equal to R times 2. Okay, D is equal to R times 2. The radius is equal to, the diameter is equal to the radius times 2. So therefore, we want to make R the subject of the formula here. So therefore, R is equal to D divided by 2. You know this, the radius is equal to the diameter divided by 2. So we are going to use D over 2 in this formula now. Okay, so therefore, our cross-sectional area now is now equal to pi d over 2 squared. We have removed r and replaced r with d over 2. We've substituted d over 2 with r. Okay, so therefore we are now at this stage of our question. So let's do a further simplification. If you do a further simplification, we're going to see that a, the cross-sectional area, is equal to pi d squared is equal to d squared, right? Then 2 squared is equal to 4. So therefore, further simplification is going to prove that a is equal to pi d squared over 4, right? So from the concept I've shown you earlier, okay, I've shown you two concepts, that if we have a constant power and if we have a constant multiplying the rest of the equation. So in this question we have two things here. We have two things. If you put a is equal to pi over 4, this is a constant, right? Then d, the variable, squared. This squared is a constant power, right? So we're going to use both concepts I've showed you earlier to solve this question. First of all, let's calculate A, the cross-sectional area, and after that we calculate the absolute area in A. So therefore, if we start by calculating the A, the cross-sectional area, we're going to find that pi over 4 times d, which is 0.56 squared. If you punch this into your calculator, if you punch this water into your calculator, A will be equal to 0.24 or 25 if we correct to the nearest two decimal places. So therefore A is equal to 0.25, right? But you're not done yet. So now we need to calculate the error in the cross-sectional area, the absolute error in A, okay? Okay, so we've calculated A, the cross-sectional area, and we found that A is equal to 0.25 corrected to 3 decimal places. Using the formula, A is equal to pi over 4 d squared, okay, where d is equal to the diameter of the wire, right? So I hope everyone is clear on how we got this formula. If you were lost somehow, you have to trace back to the video on where you were lost. Okay. Now let's start calculating the absolute error in A. and we'll be done with the question. Okay, so the absolute error in A, using the concept I showed you earlier, will be equal to the absolute error in A over A will be equal to 2 multiplied by the absolute error in D over D times the constant. Pi over 4 is the constant. So the absolute error in A now, using the formula or the concept I showed you earlier, absolute error in A over A is equal to 2, which is the constant power of D, times the absolute error in D over D, times the constant, 4 over pi over 4. This is the constant now. Okay, so then you're done. So let's simplify it further. So the absolute error in A over A is equal to 2 times, dot means times, okay? 2 times the absolute error in D over D. What is the absolute error in D? The absolute error in D is 0.01 millimeters. So 0.01 millimeters over D. What is D? D is equal to 0.56. Okay, 0.56, that is D. Okay, multiplied by pi over 4. Okay, so the absolute error in A over A is equal to 2 times 0.01 over 0.56 times pi over 4. If you punch this into your calculator, so if you punch this term into your calculator, the absolute error in A over A will be equal to 0.03 corrected to 3 decimal places. Corrected to 2 decimal places, I'm sorry. Corrected to 2 decimal places, the absolute error in A over A will be equal to 0.03. So now what is the absolute error in A? So which means delta A is equal to 0.03 times A. Right? You're getting this, right? Okay, what is A now? A, we've calculated A earlier and we found that A is equal to 0.025. A is equal to 0.25, right? So therefore the absolute error in A is equal to 0.03 multiplied by 0.25. Okay, so this is simple physics. If we punch this into the calculator, therefore we will get that the absolute error in A will be equal to 0.0075. So if we punch 0.03 times 0.02 times 0.25 into the calculator, we'll get that the absolute error in A is equal to 0.0075. That is the absolute error in A. So therefore, the final solution of what is the cross-sectional area. So therefore, the cross-sectional area now, cross-sectional area A is equal to 0.25. This is the cross-sectional area, right? And this is the absolute area in A. So the plus or minus the absolute error 0.0075 in brackets millimeters. So this A is equal to 0.25 plus or minus 0.075 millimeters is the final solution, right? So let's move on to item 2 of the question. Okay, so we've calculated item 1, which was saying what is the cross-sectional area of the wire, and we found that the cross-sectional area of the wire is equal to 0.25 plus or minus 0.0075 millimeters. This being the absolute error, and this being the cross-sectional area of the wire. So item 2 of the question now is saying that calculate the percentage error in the cross-sectional area of the wire. Okay, so you use this formula, the absolute error in A, or delta A, over A times 100 is equal to the percentage error. Right? So this is an easy one. So what is the absolute error in A? The absolute error in A, we calculated it and we found that absolute error in A is 0.0075, right? Over A, what is A? We calculated A and found that A is equal to 0.25. 0.25 times 100. Okay? So you just punch that into your calculator. You have your that into your calculator, you find that the absolute error is 3%. Then you're done. It's 3%. So my A level, especially for Zimbabwe, my A level pane vanaona my physics students anto foira kushandisa calculator. handiti pakungopanja mavalues into the calculator munhu anotadza obudisa wrong answer munhu ane calculator unofoira physics. If you're one of the students vanofoira pakungopanja mavalues into the calculator, A-level students, I advise that you improve. Okay, advising you improve. So this is your Zimbabwean physics teacher, and I'm out.